Good. Hello, everyone. Good afternoon, and welcome to our new webinar from Zero to ML platform, MLOps for building and operating ML products. I'm Marina, visiting in marketing and events at ATE. And before starting with the interesting webinar, I'm gonna list some organizational points. So, first of all, the webinar will be recorded and will be available on our ATE website. You can see also the recording in our YouTube channel. You will receive after the webinar a link with the recording. You can also ask questions every time in the private chat tab on the right, and the questions will be answered at the end of the webinar in the Q&A session in the last 5 to 10 minutes. And for you as info, only you and we can see the questions you ask, so they are private. You can also participate in the survey via the interaction tab you will see later on, also on the right side. And if you have any problems, please don't hesitate to contact me. You should see now my email address in the presentation. So I hope you are all online now, and I'm gonna present now our speaker, one of our MLOps expert engineers, Sahling. He's been working in the field for 6 years, and he's focusing on building ML platforms and has put also several platforms in production. So welcome, Kai. The stage is yours.
Thank you, Marina, for that very nice introduction. And also from my side, a very warm welcome to everybody joining today. So I'm very happy to see that many people joining, that many people who are interested in the topic of MLOps. So let's start right into the webinar. So what's coming up next for you for the next 50 to 45 minutes? First, I want to talk about the challenges of building ML products. So what might go wrong? Why is it so difficult to put ML products into production? Second, I want to talk about the solutions and how MLOps helps us to fix these issues, to tackle the challenges. And third, the most important bit, that will be the second half of my talk, how to implement these solutions. So how do we implement the MLOps best practices to easily bring models into production? And that implementation, that's called our AT MLOps journey. It's a stepwise approach. So I will show you 4 steps, starting from literally zero infrastructure to get to a very mature setup. So what are the challenges? So what is so difficult about machine learning? Well, what you have to always keep in mind, the starting machine learning initiatives, starting the projects is always fairly easy. So building the model, and it doesn't matter if it's a very simple classifier or a complex neural network, that's always fairly simple, and it will also take little time, at least compared to what it takes to later make a product out of it. And a product, well, you see here the logo of ChatGPT, and ChatGPT is right now probably the most famous machine learning-based product. And when I say product, what do I mean? Because I already used that term quite sometimes. I mean, a product is something of value. So you associate value with it. And for that reason, you also expect it to be available like 99.9% of the time. It should be also easy to understand, easy to work with, and you want to be able to release new features. You want to release updates, maybe release a new version, because ideally, of course, your customers will love your product. So you should be able to quickly satisfy what they are asking for. And why is that so difficult? Well, that step from the prototype, from the model to a product, so difficult because of all these capabilities you have to add. And in fact, quite a lot of projects fail to make that step. So there are surveys, for instance, one from Gartner, where it says, okay, 85% of machine learning projects fail at this stage or fail to make that step. And I said, okay, it takes much more time to build the product compared to the model. According to a Google survey, it's 95% of the time is spent on building everything around the machine learning model. And in my experience, yes, it is something between 90 to 95%. So now let's take a closer look at these capabilities. How does the average machine learning initiative or project looks like? Well, usually you can split it up into 3 phases. There's a design phase, a build phase, and at the beginning, there is a problem. You think you can solve that problem using machine learning. So you fetch some data, set up a prototype. And once you have that, you will enter the last phase, the run phase. You make it a product, you run it, you maintain it. So what are you using at the beginning? So what are the capabilities you need during these 2 early stages? At the beginning, you really only need to focus on the machine learning model. Sure, you need to fetch some data and you need to do some analytics work, but your focus is on building that machine learning model. However, now we want to make that step to the product. Machine learning model is no more the focus of your work. You have to add all these capabilities to make it a product. Sure, the machine learning model, it's still the core of your product. Without the model, the product doesn't work. But at the same time, without all the other capabilities, the product itself also doesn't work. And so, for instance, you also need to provide some data collection. So you want to automatically fetch new data, and the amounts of data might be very large. You need to automatically compute the features. So that's a lot of data engineering in there. Of course, you also need to manage the resources. So the resources where your training runs on. And sure, we need to talk about monitoring. You want to know what's going on in your product. You want to know how users are interacting with it. You want to know how your model performs. Or maybe let's talk about serving infrastructure. You need to serve the model to your customers, and you must serve it in a reliable and a scalable way. And of course, you need to manage all of these processes and orchestrate them. So difficult thing is you need to, when making that step from the prototype to the product, you need to provide these capabilities all at once. So, okay, now let's say, why not just build that? Is it so difficult to build all these things? Well, let's take a look at the tools you're working with. At the beginning, you can easily build a great prototype using only a Jupyter notebook and maybe some Docker. That is definitely enough to get a prototype up and running. But let's compare it to the tools you will see in the production phase. Then we might talk about a tool like MLflow to orchestrate or to track the experiments, the trainings you're doing. Maybe we need to talk about a tool like Spark to process large amounts of data. Or it's about having a platform like SageMaker or Kubeflow where you run your training and inference pipelines on. But also at the same time, we need to talk about tools, for instance, like Prometheus and Grafana. And in particular, tools like these, so Prometheus and Grafana, that's used for monitoring. It's not at all related to machine learning. So any software product needs monitoring. And for that reason, these tools like that, they are not part of the toolbox of a data scientist. The data scientist is supposed to focus on model building, setting up a monitoring infrastructure. That not a key skill of a data scientist. So for that reason, you need to add additional skills and as such additional roles to make that step from product to prototype. What does it mean? Well, we need to talk about data engineers. You might need data engineers in your project. You need DevOps engineers or ML engineers. So the ML engineers, they set up the training pipeline, the inference pipeline, or maybe you even need MLOps engineers like myself to set up the infrastructure where the training pipelines are running on. Or maybe you even need risk managers. So the European Act on AI, it's up on the horizon. So in the future, it might be a requirement to have someone who assesses the risk of a model of a product. So might it pose any risk to your customers, to your users, to your company? And so keep in mind, you need to get all of that at once. That's what makes that step so difficult. And now, let's say, okay, you managed to get all these people, you managed to get all this tooling, you set it up, and you made it to production. Well, it's a great success, definitely, but it's only the beginning. So getting from a prototype into production, yeah, it's a challenge, as we have just seen, but I'd say many organizations figured that out. Sure, there is quite some room for improvement, but maybe 5 years ago, that was the main challenge. But today, it's more about operating that product and to maintain it, keep it up and running. So that's what brings in the complexity. For instance, what might happen? You have something running in production. Of course, you need to apply updates. So it might sound super mundane, but of course you have to apply security updates. Maybe the pandas library has some issue. You need to fix that, and you need to be aware of that. What else might happen? Well, of course, you want to release new products. So customers will like your product. You want to bring out a new version of it, add new features to it, and everything while still maintaining an existing one. And when you have no plan how to do these things, that's what will end you up in a really unmanageable state. And that's what we see with our customers again and again. So they have some products running, but they really end up in that stage of huge complexity. It's hard to manage all these things. And you will see without any plan how to do that, there will be a shift to maintenance. Maybe you manage that when it's about deploying the first model or product, maybe the second one. But of course, you not only want to have a few products up and running, but as a large organization, I'm sure you have use cases for dozens of products. So you want to have quite a lot of them up and running. And once you have that shift to maintenance, that focus shift, the delivery pace will definitely slow down. And that's, as I said, that's what we see. Customers, they have quite a large backlog of use cases, but they simply do not manage to release all of that because the focus is on maintenance. And once you're in that stage, it's also very error-prone because the teams, they struggle to keep everything up and running. They focus on that. They apply quick fixes, but there's no time to think about how to make it better, how to standardize it, how to share ideas, how to tackle these issues. And for that reason, you will also see quite a lot of duplication of work. Okay, so now that might sound terrifying, but of course, there is a solution for that. And that solution is obviously MLOps. So what is MLOps for us? It's simply, the next logical step. Let's put it like that. So it helps us to bring your prototypes into products and to maintain them, to operate them successfully. And anything that helps you to do that, that's MLOps. And I'd say really it's the next logical step. So the industry, last 10 years, we figured out how to work with these machine learning models, but now it's about to get value out of it. A prototype doesn't yield any benefit. It's worthless, essentially. Only if you make it a product, only if you make it available to your users, to your customers, that's how you get value out of it. So that is really the next step we have to tackle. So, as I said, we need to talk about the 3 categories in here. So when you define how to do machine learning right, it's about processes. So you want to define how to work together in a team and across your organizations. Second, it's about operations, or you might also call it automation. The goal is to be on the loop instead of in the loop. That's really a term I like very much. So it means in the loop, you focus on that maintenance. The system is in control of you, basically. You check the logs each and every day. You check them to see if it's still working or not. And well, I consider that somewhat the holy grail of MLOps. So on the loop, that means you are informed about what's going on. The system tells you what went wrong, where the issues. And third, maybe the most important bit, it's about compliance. So doing machine learning right means you do it in a compliant way. So let's say you build the best ML or the best model there ever was, but if it violates any internal or external regulation, you simply have to shut it down. It doesn't matter how good your machine learning product is, you have to shut it down. That's it. And so, to sum it up, what you should really keep in mind, MLOps, it's simply about how to do ML right. It's not getting a tool, a platform. It's not about buying the best tool there is. You define within your organizations how to do it right, and you provide the means and tools to your team and to do everything in a compliant environment. So now, how do we define how to do it right? Well, we use best practices. Best practices, they will guide us. So based on these best practices, we define how we want to work together. Then it helps us to pick the tools, pick the technology. And once we have that, we are able to figure out how to make everything compliant. I always recommend to define these best practices for yourself, for your organization. We at IT, we defined 5 best practices. So we say machine learning, it should be collaborative, it should be reproducible, it should be automated, it should be monitored, and it should be tested. How do we implement that? So collaboration, for instance, we want to reuse components. So we want the teams to be able to share their work to ultimately reduce their workload. And reusable components also means less components, and as such, components of higher quality. Reproducible, well, of course, we want to have the code, the data, and the models versioned. And automation, well, here we are talking about the pipelines, a training pipeline, inference pipeline, but also CI/CD pipelines. Monitoring, we want to have these alerts and triggers. So we want to be informed about what's going on in our product, how our model is performing. And sure, of course, we need tests. So the more you automate, the more tests you need to add. So we want to have these. These are sure tests like unit tests, so basic software engineering tests, but also tests for the plausibility of your model, and maybe even tests for inclusion. How does it help us to set up an compliant environment? Well, reusable component, as I said, it means less components, and as such, less components to audit. Reproducibility, if you can reproduce any state of your machine learning product, you're also able to trace back any kind of failure. So let's say customer complains about a decision a model made. If you're able to recreate that state, you can figure out what went wrong and ultimately explain it to your customer. Automation, once you are able to quickly bring new models, new versions into production, you're also able to quickly react to any shifting regulatory requirements. Doesn't matter if it's internal requirements or external, like maybe the upcoming European Act on AI. The monitoring, of course, if you're informed about what's going on, you know that something went wrong and you can trace that back. And the test, as I said, you might need, or you might want to set up tests for inclusion. So let's say you have a user group which is of high interest for you. So you make sure that for that user group, the model definitely works, and not only in average across all users. And well, based on these best practices, that helps us to keep that complexity down once we are in production. And well, when do we start with it? Definitely as early as possible, ideally at the very beginning. So when you start your machine learning initiative, your project, start thinking about how to operate it. Define these best practices, and based on them, choose the tooling. Maybe you set up reusable components, you share them with others, you set up the monitoring. So you, where you implement these best practices, and that will definitely help you to keep the complexity down. That will help you to end up in a sustainable environment. And yes, it's a challenge. So at the beginning, it will take more time, but it will definitely pay off. So it's an investment. If you define these things at the very beginning, it will definitely pay off later on. You will end up with fewer maintenance work. So the transition from the prototype to production will be easier. You will be able to bring more models into production, to test them quickly, and to quickly react to your customers' demands. You will see a sustainable delivery pace, so your work will not only focus on the maintenance, but you will be able to work on new products, and that also means, okay, there will be less maintenance, and generally the collaboration between teams will be easier because, for instance, you have these shared components. And now, before we jump into the second half of my talk, I'd like to know from you what has been the biggest challenge when working on a machine learning project? So is it building the model, or is it about the data? You will see the question pop up in the chat. So please hit that button. I'm really interested to see that. Or so data might be an issue. Is it the data quality, or is it setting up the infrastructure to run the training pipelines, to run these inference pipelines? Or maybe is it about setting up all the monitoring for it? So these 4 categories you see in there, these are 4 categories we use to evaluate the machine learning maturity of our customers. So I'm really curious to see what you guys say. And let me take a sip of water, and then we start into the solution. Okay, I hope you guys have answered the question. We will take a look at the results once I finish the talk. So let's jump into the implementation. So as I said, that's called our MLOps journey. And we start with the prerequisites. So at the very first thing we do is we set up the basics. And not like the basics of machine learning, but the basics of basically modern software development. So we want to have version control in place. We want to have CI/CD pipelines up and running, and we want to set up everything using infrastructure as code. And really, only if we get these things done right, then we can talk about machine learning. And you should never think about buying a tool like a feature store before you get these things done right. Okay, once we have that, we move on to build the foundations for our ML platform. And at this stage, we want to introduce the pipelines. So we want to split our training or our inference into smaller steps that we can easily work on, share, and I will talk in detail about how the pipeline looks like in just a bit. Many pipeline tools also provide some experiment tracking, so like MLflow, so definitely go for that as well. Like Azure ML, SageMaker, they already have that out of the box, so also set it up. And also invest in the data catalog, or don't invest is the wrong word. Don't buy a tool, but set up some documentation for your data. So whatever data you work with, write it down, what you have used, what transformations you have done. If anything happens in production, if there are any errors, it will be a great help to know what data you have used. Once we set that up, we can go on and scale that platform. So scaling now, it's not about now you have 10,000 users and next you want to have 10 million users. It's more about scaling your organization's capability to deploy and run these products. So for that, you need monitoring, alerts, you need automated releases. That will help your team to run multiple products at once. That will have help your organization to have many teams, again, working on multiple products. And the monitoring, that will help us to figure out what's going on. That will tell us, hey, an error occurred there, take a look at it. And the automated releases, it simply reduces the amount of manual intervention in your system. Again, also it decreases the amount of time that's spent on, maintenance tasks or tasks that are not used to build a new product to improve the existing ones. So at the last stage, and that will be a very mature setup, and probably when we later take a look at it, I'd say very few companies in Germany have that kind of setup. So at the end, you want to even more strengthen or foster your reusability. You want to invest in even more automation. And then we can talk about buying some tools, maybe a tool like a feature store, or you want to set up data lineage or a components library. And now, before I jump into the architecture of these platforms, let's take a quick look at how the teams look like at each of these stages. At the beginning, I highly recommend to have a central team in place. So you want to have one team that's in charge of building up all these capabilities. That team must get the backing of your upper management, and they are enabled to make these decisions, how to build the platform, what tools to use. Once you have many teams working on use cases, that central team might become a blocker, it will become a bottleneck. So I recommend to then start shifting power from that central team to these teams working on the use cases and enable them to actually work also on the infrastructure of your platform and maybe to contribute to it. At the end, I'd say that central team should be more like a guild. So across these different teams working on the platform, they agree how to improve the platform, what new tools you want to integrate, but there's no more that one central team. Instead, these people who have before worked in the central team, they are split across the actual use case teams, so the teams which are building and running the products. Now, let's start to look at how these platforms, how these stages look like. Let's look at the architecture. How do we start? Well, the easiest way to deploy a model is simply fetch some data, put it on your local machine, do the exploration in there, and create a model. Once you have a model you're satisfied with, maybe simply put it in an S3 bucket, and you have that model there. You set up another service which picks up that model and can serve incoming requests or maybe run a batch job once a day to calculate predictions for your user base. That setup can work. It can definitely work for, let's say, a small startup where that model is like the only product, but that's definitely doesn't work in a large organization. So why doesn't it work? Well, you train on your local machines, so there's no chance for others to contribute to see what you are doing. Simply not transparent. And of course, having your data locally, that might violate some internal regulations. So in particular, if the data is about, if it's PII data. So if there are sensitive information about your customers in it. It's also very error prone because there are no tests involved. So at least there are no automated tests that are enforced somehow. Sure, you can write your own tests, but nobody is forcing you to do that. So at this stage, let's take a look at our best practices. And obviously, we do not fulfill any of our best practices we have set up before. So it's not collaborative, it's not reproducible, not automated, not monitored, and not tested. Let's improve that. As I said, start with the prerequisites. So we still need the data, we still want to do an exploration, that doesn't change, but it's no more running on your local machines. It's running in some safe, maybe in cloud environment. So for instance, you can set up a Jupyter Hub on Kubernetes or use a tool like SageMaker where you also have these notebooks. Once you have something up and running for you or something working for you, you definitely want to put it in a source repository. So you want to have your code version controlled. And using this code, you set up a CI/CD pipeline to build your ML job. So inside that machine learning job, all the training happens. And in addition to the training, there will also be some data preprocessing. You evaluate the model and store it somewhere. So the output, well, as I said, it's just the model, but now you also put it in a model registry. So it's versioned, and if something happens, you can go back to that very version of the model and check why some error might have occurred. You can indeed use an S3 bucket, but at least enable the versioning. And okay, once we have that model in our registry, there's another CI/CD pipeline to deploy the service containing that model. You can run some tests in there and then have your ML service up and running to serve incoming requests or to do some batch prediction. What did we get here? As I said, get the prerequisites, right? So you have the CI/CD pipeline. You are able to test your software thanks to the CI/CD pipelines, and your models are versioned, and as well as your code, obviously. How did we improve? Well, collaboration, it definitely improved. So you have your code version, other can work on it. Reproducibility, yes, we've got that a bit. We have our model registry. We have some sort of automation. So we have the CI/CD pipelines. There is no monitoring yet. Sure, the ML service creates some logs, but that's not good enough for us. We want to have some proper alerts. So nothing yet in that category. And we have the tests. So the CI/CD pipeline, they enable us to run some tests to check our models, maybe for plausibility. Now, the next step, it's about introducing the machine learning pipelines. So instead of deploying one large training job, you split this job into smaller steps. So it's somewhat the same idea as microservices compared to a big monolith. So you want to split the training into different steps. You have the data preprocessing step, you'll have the data preprocessing step, the training step, the evaluation step, and you store the model ultimately, the last step. You can add even more steps for sure, but that's like the minimum setup. These smaller steps, well, as I said, they are smaller so that they're easier to understand, they're easier to maintain, and at the same time, you can share these steps. So let's say I build a great data preprocessing step, then I'm able to share that with other teams. So maybe, okay, you have a few data sources. I build a great connector for one data source. Other teams also need that source. So I share that step with them. And now let's say I'm working on the data preprocessing, somebody else working on the training. I do not have to care about what's happening inside the other steps of the pipeline. As long as we agree on how to pass data from one step to another, I'm good to go. I don't have to care how the training steps looks at the inside. I simply pass my data to the step and I know it will work. Here, you also want to have the experiment tracking. So you want to set up a metadata store to store your training results. So you want to store what model you used, what version you used, and how the model was configured. That allows you to compare different models to find the best one. And let's say you touch it again after half a year, you can see what you have already worked on. So there's no risk of duplication of work, or at least it's way smaller. And well, the output of the pipeline, it's still the model you put in the registry. This stage, we also want to introduce different environments. So at the top, there's the dev environment, and at the bottom, that's the staging and prod environment. That's usually how I split it up. So I have the training and building the pipelines, that's dev, and you have the exploration and the setting up of the pipelines. That's part of the dev environment, but the actual running of the pipelines and the serving of your model, that's part of staging and prod. Sure, you can also put the training run inside a dev environment and maybe have only the inference setup as part of staging or prod. That also works, depends on the use case. What else? Well, we already have the CI/CD pipeline to serve the model. That doesn't change. You also want to introduce the data catalog here. As I said, just note down what data you're using, what's inside there, what's the business context of the data. Note it down somewhere, even if it's only a Confluent site. Will definitely pay off in case anything happens later on in production. So what did we get? We have these reusable steps. We split the training job up into different steps. We introduced the different environments, and data exploration is faster because we make sure we document what we are doing with the data. How did we improve? Collaboration is much better thanks to the pipeline. So thanks to now we are able to work on different steps independently of each other. Reproducibility is better. We have the metadata store. Automation slightly increased. Well, we have the pipelines. Monitoring, at least we have some monitoring for the training. So thanks to storing the metadata. And the tests, well, we already had the CI/CD pipeline, but having the machine learning pipelines, that also allows you to have some more steps in there for specific tests. So let's say you have your heavy users that generate most of your revenue, and you definitely don't want that the new model will perform less for this very group. So you set up another test step inside that pipeline to, well, control that. Now it's about scaling. So I said in here, we want to automate the releases and we want to introduce the monitoring. So automated release, how does it work? Well, we still have our model stored in the registry, and now we use an approach called the champion model. So the model that's currently running or is already running in production, that's considered a champion model. That's the best one you have. And every new model you train, that's the contester model. So when you train a new model, you compare its performance metrics to the champion model, and if it performs better, you automatically deploy it. If it doesn't, well, simply lies in your model registry. And well, as I just said, not only use these performance metrics, but also test for inclusion. As I said, test for this very important user group. So you might say, okay, I only ever deploy a new model if it still works for my heavy users. So even if a new model on average, it's better than the current champion one, but if it performs worse for that important user group, you still don't deploy it. You want to set up the monitoring. What do you monitor? Well, monitor or track all data that's coming in to your service and store all the predictions you make. Of course, if you're serving 100 million users a day, do not store all the predictions you make, but store a significant subset of it. And that will help us to evaluate how your model performs in production. So we let's say you have a forecast model running. So make a forecast for sales data, and you make the forecast for next week. So today you make the forecast, you wait 1 week to get your actual values, and that's how you can compare your forecast to real values and calculate, for instance, the accuracy, so your model performance. And you set up a dashboard, plot that accuracy over time, and you see, okay, the model performance decreases. And I can already tell you, so every model will deteriorate over time. So the performance will definitely go down. Some models, it takes longer, sometimes takes shorter, but that will definitely happen. Once you notice something like that, you trigger an alert, and it tells you, hey, take a look at it. You might have to retrain the model, or maybe build a completely new one. What did we get? We have the automated deployments. We track the model performance in production, and that allows us to act preemptively in case something happens. How did we improve? Of course, the monitoring now is much better. Also reproducibility because of the monitoring, so we know what's going on, and maybe add even more tests. Again, the more you automate, the more you want to test. At the final stage, it's about improving automation, improving reusability. So one way of doing that is to make each step its own Python package, for instance. So you can share these Python packages across your organization. If someone updates such a package, everybody can still pull it, install it via pip, get the newest version, and everybody using that step, that package, has the latest version of it. We have once built that together with one of our customers, and that really worked very well. And here you want to add, I'd say, even more monitoring, so also monitor the quality of your data that's coming in. If the incoming data no more looks like the data you have used for training, you already know the model's performance will go down. And at that stage, you also want to have automated triggers, so you automatically trigger retraining. At this stage, at the top left, now we can also talk about feature stores to even make your data sets reusable. So let's say I find a great features which describes perfectly my users. I put it in the feature store. Other teams can use it as well for their models. What did we get? Features are reusable. Pipeline is even more modular. We have the automated failure response. And at that stage, all of our best practices are fulfilled. So that's really the perfect setup. It's very advanced. I'd say only a few companies have that. And for you, if you're at the beginning, I'd say go for the third stage, the scaling phase. And only once you have that, think about going for that really fully mature machine learning setup. Before we call it a wrap, I quickly need to talk about LLMs and MLOps. So maybe you say, okay, that sounds super complex. I don't want to deal with that complexity. I simply want to use ChatGPT for it. So let's take a quick look how that architecture looks like in case you decide to go for such an LLM. What do you still need? Of course, you still need the data. That doesn't change. Now you introduce your LLM API. So right now, I won't talk about training your own LLM. That's a topic for another webinar. But let's say you simply use that API. What else do you need? In many cases, you really need a vector DB. So that's a use case what many of our customers approach us with. So that's this typical talk to your data use case. So you want to use a chat to talk to your organization's knowledge. So for instance, find something in Confluence. And LLMs are very good at finding some information or summarizing information within some given text. But of course, you cannot simply put all of your Confluence, for instance, into that prompt and pass it to an LLM. That's, of course, way too big. So what you want to do is you want to find the relevant information within Confluence, for instance. So find the relevant pages you're asking for, and then only pass these pages to the LLM and get a response. For that case, you need a vector DB to get this relevant information. It's doing a semantic search. And that step from data into a vector DB, that's already very challenging. So definitely don't underestimate that. You still need exploration. Of course, you want to do tests. You no more train a model. You simply use the API, but you want to try out different prompts. Maybe you want to try different LLMs or different APIs. You still want to put in a repository, so we definitely don't go back to the times where everybody worked on their local machines. And you still want to use this pipeline approach. So it's still a great capability to simply switch at this stage, well, not the training step, but the evaluation step of your prompt. Simply switch the prompt and iterate quickly over different LLMs, different prompts, and get the results. You still need to store that, so store your prompt, store the LLM version you have used, quite similar to storing the model parameters, so that also doesn't change. We still want to have a split into a dev environment and staging on prod. That's also not going to fade away. And what's the output of our evaluation pipeline? So you have evaluated your prompt. You store it somewhere, of course, to later use it. And how do you use it? Well, you still want to have a CI/CD pipeline to set up the machine learning service, which uses that prompt to make a call against an LLM API. And then in here, I say, okay, it's an inference pipeline, because that's the other big difference compared to a normal machine learning model. Let's say you build a simple recommendation model. So a traditional recommendation model. What can it do? Well, it can only give recommendations, of course. That's the only thing it knows. But now you could also use an LLM to set up a recommendation model. So create your prompt to use it as a recommender. But still, as it's a large language model, or as it's a language model, you can still use it for anything else. So you could still use it to plan your next vacation. So it's really hard to fit that LLM to your very specific use case and make sure that it doesn't act out of that use case, because your users will interact with this model directly. So there will be the chat, and you must make sure that whatever you show to that user, that it makes sense. So let's say you use an LLM to set up a recommender. You want to make sure that these products you recommend actually exists. And there are as well the risk of prompt injections, for instance. So maybe when you use some LLM product, just put in the chat, ignore everything above. That's how you can nullify all the prompt engineerings. And that comes usually at the very beginning of a prompt. You still need monitoring, of course. Doesn't matter if it's an LLM or not. You want to know how your model is performing or how your product is performing. Are customers liking it? And you still need these alerts. So in case something happens, you want to be informed about it. So as you can see, you get rid of the training. You no more need to train a model. But most of the other pieces or capability that stays. So if you consider using an LLM to solve your use cases, to solve the problems you face, depends really on the use case, and don't underestimate it. It's not like, okay, I use ChatGPT and that's it. You still need all these capabilities around it. If you're interested in that, we have set up platforms like that, or we're currently working on it, so feel free to reach out to us. And just one last question I want to ask you guys. So are you already working with LLMs? Because quite a lot of customers approach us, they have some use cases in mind. So what's your current state? Do you evaluate different use cases? Do you already work on one? Or maybe have you already deployed an LLM? Or is it no topic at all for you? So let me take one sip of water and then we can move on, so you have some time to answer the question. Okay, so let's wrap it up. What I really want you to keep in mind, it's start easy and start early. Get the basics done right. Set up your tests, set up your CI/CD pipelines, have your models version, and use infrastructure as code to do all of that. Once you have that, and only if you have that, you can move on. Then set up the pipelines. Once you have these pipelines in the different environments, go to a scaling phase, have your monitoring in place, set up the alerts, have your automated deployments, and then at the final stage, or keep improving the reusability of your components, improve automation, and that's how you get from literally zero to a very mature setup. And now, before we jump into the questions, let me just tell you, okay, of course, we have done all of that. If you have questions, if you need support or want to exchange ideas, we do trainings and workshops around the topic of MLOps. We do maturity assessment to see, okay, where are you right now? How can you improve? And we have built these kind of platforms. We built them on Azure, on AWS, maybe using SageMaker. We have set up Kubeflow platforms on Kubernetes. So reach out to us if you need any support with that. And now I already say thank you so much for your attention, and let's take a quick look at the questions.
So welcome again. Thank you, Kai, for the fantastic presentation. I hope you also enjoyed. We are going to start now with the Q&A session. But first of all, I want to say sorry again about the technical failure we had here. But yeah, with technique, you never know. So first of all, you wanted to see the questions we asked to the participants. So what is your biggest challenge when building ML products?
Okay, so what do we have here? Okay, data and infrastructure, that's the most urgent problem. So, well, it kind of fits what I usually see when I do this sort of maturity assessment. As I said, people have understood how to build a model, so that's no more an issue, but setting up the infrastructure, and I'm a bit surprised that we only have 3 people who voted for monitoring. And well, data quality is always an issue, so I'd say maybe usually monitoring is more, but the rest looks like what we usually get.
It's what you expected.
Yeah.
Okay, now we are gonna see the next question we asked you. Do you already use or plan to use LLMs? No plan yet, 33%. Evaluation use cases, 56. Building a prototype, 11. And now one is running in production. Yeah. Okay. Do you expected that?
Yeah, I'm a bit surprised that there's people who do not plan to use it. Feels like everybody is at least talking about LLMs. So yeah, and that's also what we see. Well, most of our customers, they have some use cases, they have some rough idea, and they are evaluating how to make that work. But yeah, we are also just building, so we're in the phase of building up these different platforms or these different products. So yeah, great to see that there are quite some people who are already thinking about it.
Yeah. Well, we have time for some questions. So the first question we have here is, what is the difference between ML job and ML service exactly?
Okay, yeah, that was on the second architecture slide. I just wanted to make clear that at the beginning, the ML job is well, one big job to have the training run in there. So that job includes also the data preprocessing, it includes the evaluation of the model, and well, storing the model. So it's all one big service. And that's what we later on want to split up. The ML service, which was at the bottom right of the architecture, that's but it's used for making these predictions, making the inferences, making recommendations. So how to serve the model to your customers. That's the difference.
Okay. And next question. Why does the model quality deteriorate over time?
Yeah, good one.
Good one.
I think the best example is let's think about Facebook. So they, of course, they have a recommender running. So, and let's think about how people use Facebook today and how it was used 10 years ago. So the usage pattern greatly changed. So there are other people using it. I'd say fewer people are using it, but behavior on that platform changed. So if you use the data from 10 years ago, the Facebook data from 10 years ago, to now build a recommender, of course, that doesn't work, because the patterns we have seen 10 years ago doesn't match the patterns that we see right now within across the user base. And for that reason, you have to make sure that your data set matches the patterns that you right now see. And these patterns, these usage patterns, for instance, they change definitely. So only change as a constant. So change is the only constant. So that's the reason why performance usually deteriorates.
Okay, so we have to be careful with the data we use.
Yeah, make sure it's at least somewhat up to date.
Okay, I think we have time for one more question. So what tools can you recommend for ML pipelines?
So yeah, I made really good experience with the tools that are already provided by the big cloud providers. So on Azure, Azure ML is fairly good. On AWS, it's SageMaker, and on GCP, it's Vertex AI. So if you are already on such a platform, definitely take a look at these. They cover most of the use cases, so that's definitely a good tool to use.
Okay, good to know. Well, we are fast finishing the webinar. So first of all, for you as information, if you have asked some questions and we didn't have time to answer it, you will receive with the email with the link for the recording, also a link with a PDF document with all the answers to the questions regarding the webinar.
And one thing I want to add, so if you're interested in the slides, we won't upload them somewhere, but if you want to get them, simply send me an email, reach out to me on LinkedIn. I can share that with you. That's no issue.
So thank you again for being here and have a nice day. And thank you for the presentation.
Thank you. Bye.
Bye.